On our last video lecture, we left off trying to determine whether we should remodel the old car wash or remove the old car wash and install a new one. Well, our discount rate is 10%. That is our accelerated rate of return is a 10% rate. Here's what we know. If we decide to install the new car wash, we'll have $90,000 annual revenue. Cash operating costs will be $30,000, and we'll have an annual net cash inflow of $60,000. If we continue with the old car wash and have a remodel, where we get $70,000 in annual revenues, operating costs will be $25,000 on an annual basis. Excuse me. Annual net cash inflows would equal $45,000. Okay. Here's some other information. To install the new car wash, we'll spend $300,000. It will last for 10 years, have a salvage value of $7,000. At the end of 6 years, we have to replace all of the brushes that'll cost us $50,000. And at the end of 10 years, we can salvage or sell the equipment for a cost of $40,000. Okay? So here are our calculations for installing the new car wash. The initial cost we're going to spend a day would be $300,000. Okay? To replace the brushes 6 years from now, their present value is based upon a 10% discount rate is $28,200. Now the annual net cash inflows was $60,000. That's what we receive each year over a 10-year period. So once again, it's the present value of an annuity. Their present value is $368,700. Now, if we buy the new equipment, we can sell the old equipment now and receive in cash $40,000. At the end of 10 years, we can sell the new equipment, which would then be the old equipment. So that's $7,000 received 10 years from now, based upon a 10% discount rate, has a present value of $2,702. In conclusion, if we decide to purchase the new car wash, it has a positive net present value of $83,202. So the new car wash will give us our required rate of return and more. Now, let's compare it against replacing or remodeling the old car wash. The remodeling cost will be $175,000. At the end of 6 years, we have to replace all the brushes, and that will cost us $80,000. So we take a look. The initial investment today would be $175,000. At the end of 6 years, we replace all the brushes, and based upon a present value, a rate of 10%, their present value will be $45,120. Remember, by doing remodeling, we're going to receive $45,000 net cash inflows each year for the next 10 years. Present value $276,525. So overall, if we decide to remodel the old car wash, it does give us a present value of $56,405. So notice that both alternatives will give us a positive net present value. However, investing in the new car wash has a higher net present value than remodeling the existing car wash by $26,797. So based upon these factors, it would make more sense to invest in the new car wash rather than to remodel the old car wash because the new car wash would give us a higher present value than you would get with the remodeling of the existing car wash. So that's the approach we're going to take when we have different alternatives to see which one yields the highest net present value. Okay? Now, in decisions where revenues are not directly involved, managers should choose the alternative that has the least total cost from a present value perspective. So we're saying that sometimes there may not be per se revenue being generated. However, one option may reduce more operating costs than the other. So we're saying that whichever option will result in a lower cost, then we should choose that particular approach. Okay? For example, we have home furniture company trying to decide whether to overhaul an old truck or purchase a new truck. They're using a 10% discount rate. So these are the factors. Notice that there isn't any per se revenue involved in this decision. But we will take a look at to see which approach will reduce operating costs the most. So the old truck, if we overhaul it now, that cost would be $4,500. We would spend $10,000 a year in operating costs. Salvage value in 5 years would be $250. So if we kept it for 5 years, we can get $250 for it. Or if we sold it now, we can get $9,000. In comparison, the new truck costs us $21,000. Operating cost is $6,000 per year. And at the end of 5 years, we can sell the new truck and receive sales value of $3,000. So let's take a look. First, we begin with the new truck. Purchase price, $21,000. The annual operating cost is $6,000 per year for the next 5 years. So again, look at the present value of an annuity. You would go to I equals N. N equals 5. I is 10%. Your factor would be 3.791. This is the present value of the annual operating cost. Now, if we bought the new truck, we can sell the old truck now and receive in cash $9,000. At the end of 5 years, we can sell the new truck for $3,000. That's the present value of a single sum received 5 years from now. So N equals 5, I equals 10 to find your present value factor. So the NPV of the new truck is a negative $32,883. Compared to the old truck, we would spend $4,500 today to get it overhauled. We're going to spend $10,000 per year for the next 5 years. So once again, you're looking at the present value of an annuity. That factor is 3.791. The old truck, if we were, when we sell it 5 years from now, it has a sales value of $250, which means today it has a present value of $155. So we can see that both decisions have negative present value, but which one is less? That's correct. If we buy the new truck, we see that it has a smaller negative present value than it does to overhaul the old truck. So we will actually save money by buying the new truck compared to overhauling the old truck. So sometimes there is not any revenue involved in our decision-making process. In that case, we're saying which alternative has the least cost. So whichever alternative has the lowest net present value, we want to choose that particular alternative. Last topic, focus on an investment that has uncertain cash flows. meaning that we're not quite sure of the cash flow that's going to be received. Assume that all cash flows related to an investment in a supermarket have been estimated except for its salvage value in 20 years. Okay, so we've done all the estimates of the investment except for the salvage value. Using a discount rate of 12%, management has determined that the net present value of our cash flows except salvage value is a negative $1.04 million. This is saying how low will the salvage value need to be to make this investment attractive. So we try to look at an investment into a super tanker. And we know everything about the investment except we don't know what will be the salvage value, meaning that at the end of 20 years, we can sell this super tanker, but for how much? And we're saying we don't know. So the question is, what would have to be the salvage value of this super tanker in order to make this investment sound attractive? So we take a look at the net present value to be offset, which we're saying is going to be $1,040,000. Divide that by our present value factor of 0.104. Okay, and that's because here we're saying we determine the net present value of all cash flows except salvage value would be a negative 1.04. So what we're saying here is that in order for this particular investment to be attractive, the super tanker must have a salvage value of at least $10 million. Again, in order for this investment to be attractive, the super tanker must have a salvage value of at least $10 million. Otherwise, we would not choose to take on that project. Last thing, rank investment in order of preference. So we're saying that we can do that screening decision to make sure that they meet the required criteria. And then once we have different alternatives, we'll rank them from the most appealing to the least. So because you may have 3 projects that all have passed through the screening decision. So we're saying which is the most appealing compared to the least appealing. Okay, so when using the internal rate of return, we're going to rank our projects on what we call the preference rule, which pretty much says that the higher the internal rate of return, the more desirable that project. So if I have 3 different projects using what we call the IRR approach, internal rate of return, we're going to accept whichever project has the highest rate of return. Okay? Now with the net present value approach, often it's kind of hard to just look at one project, not be compared to another, to a net present value of another project, unless the investment are all equal. So we're saying here is that with the net present value approach, because there's different cash inflows, different cash outflows, we can't necessarily just compare one to the other based upon NPV unless the cash inflows and cash outflows are going to be equal for those different investments. Okay? So this last approach is what we call the index approach. And pretty much we're going to say the higher the index, the more desirable the project. So if I take my net present value divided by the investment required, that would give me my index. So for this case, we would choose project B because it has a higher index than project A. So this is ranking projects based upon what we call their probability index. Okay? This will conclude our discussion on Chapter 14, focus on the different capital budgeting decisions. Okay? Hope you enjoyed it. Have a great day.